Yep. Okay. So welcome to the 2028 APEC Groundbreakers Virtual Tour by APEC OUZ. And this year, our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. And please remember to register to as many sessions as you can. And all sessions would be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with speaker at any time during that 2-week session by posting questions or comments directly in the session page. So first things first, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. And now for today's session, getting started with deep learning for enterprise Java developers by Suyash Joshi. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any questions during the presentation, please feel free to contact me at any time in the chat tab of the Zoom webinar. Now take it away, Suyash.
Thank you very much, Nelsie. I'm very excited to be presenting to you all. My name is Suyash Joshi. I'm dialing in from San Francisco. It's late in the evening here, but wherever you are, whenever you're watching it recording or live, welcome. I will start my screen share. So we can start with the slides first. And let me go to slideshow mode. So yeah, I'd like to thank the community for organizing the APEC OUC community for organizing this virtual Groundbreakers tour. It's very exciting to see so many exciting topics being presented in different languages and at a convenient time for people in APEC. And I am going to talk about machine learning, specifically deep learning for Java developers, enterprise Java, because that's what I focus on, and in the context of cloud. So you can tweet anything you like. These are some hashtags you can use if you share it online. So I'm going to stop my video so we can save the bandwidth, and I'll go into the slides. Safe harbor statement. The lawyers have me put this one, so you can read through this. Not very straightforward. What we're going to talk about, I already told you a little bit about myself. A little bit more, I actually am also a magician, and in my free time. In my past life, I was an enterprise Java developer. Now I work in Oracle and developer marketing and relations. I also happen to run a few meetup groups locally, so I'm very involved with the community evangelism and community advocacy side of things. And I'm a big fan of Java, and I'm glad to see those who are here and those who will be watching it. You're excited about this topic, even during these days when it's tough. The big picture around AI is that AI revolution is happening at a rapid pace, and the reason you're watching this, I'm sure you're excited about it, because we can now make applications that can solve very hard problems, from natural language processing, computer vision, recognizing patterns in data, even doing question and answer reasoning, for example, chatbots. And these things are getting better every day. And this is not something new. These problems were tackled in the past with different kind of methodology. Old school machine learning, and even before that was rule-based computing, or a thing called good old-fashioned AI or expert systems. And right now, these problems are being solved very well because of deep learning. And this is not to say that deep learning is the only solution or the only technique, which we'll talk about today. Future may be something different, because the goal of AI is to make a general intelligent agent. We are so far in in the time of narrow AI. The AI is smart, but only for a narrow field. It can only understand language in certain context or pictures of certain types based on the training set. Future, we would like technology to be intelligent, truly intelligent, without, having to teach it tons of data. So that's the vision. But deep learning is right now making a lot of things possible, from voice to text, speech recognition, personal assistant, to facial recognition, complex video classification, self-driving cars, recognizing fraud in credit card transaction, for example, or any kind of financial, medical diagnosis, question answers, automation, chatbots, agents, dialogue agents. So how is all of this done? The term, if you're new to this, is called deep learning. But deep learning is a subset of machine learning. So machine learning is a bigger picture, and deep learning is a subset. And the unique thing about deep learning is that it requires large amount of data. Generally, machine learning doesn't need large amount of data, but deep learning, the classic machine learning, didn't rely on large amount of data. Deep learning does, and it runs. Generally, these models are so big, and the training time it takes so much training and so many resources that it's best to do them on top of a GPU. And the library popular is called CUDA. It's by NVIDIA, runs on NVIDIA GPUs really fast. And there are other companies innovating and creating their own libraries to be able to run on different GPUs and even CPUs. But yeah, deep learning is the magic. So what does that look like in terms of software engineer or enterprise Java developers lifecycle? So as Java developers, you're probably very familiar with the software lifecycle, right? Where you write some code, put it into test, and then put it into production or deploy it, and you monitor the code. And the machine learning lifecycle, it kind of is very similar, but it has some other steps in the beginning. So this image I got online, it explains really nicely, especially in the context of ML engineering. So for example, the first step is generally you build a machine learning model. To build a model, you need large amount of data, generally called training data. And you also need a code. You need to write some code. And these codes are written using machine and deep learning frameworks like TensorFlow, PyTorch, talk about Java frameworks, DL4J, DJL, some other frameworks out there. And then once you're done training, the next step is generally you want to test the model, test the accuracy. I've trained it on 100 or I don't know, millions of images of, let's say, people, and I want to show it a different image of a car, of a robot, and I want to and some image of people, and I want to see how accurate its classification is. So we call that step model evaluation or testing. And then if the model is not performing very well, then we do more training, or we optimize the model. We change its hyperparameters, and we change the algorithms that it's used for training, the code. And until the model is performing at a rate and at the accuracy that we desire, we take the model and we put it in production. And in terms of cloud, how we do that is generally we create something called a model repository on the cloud, from where your application, your enterprise app, can grab the model. So a model repository is nothing. It can be as simple as an object store. So in Oracle Cloud, we have Object Store, which is a low-cost storage service where you can store these models. And these models are large binary blob files. So it's best to store them in such kind of data store. And then when you want to request it in your app, you request it over REST APIs. And the modern way to do that would be through a microservice that would request the model from the object store. The microservice would live in a container. So it could be in a Docker container. And so, for example, in Java, This could be a Helidon application, and that talks to your front end or your client. And then there's also testing. Testing happens both, in the model testing phase, but this testing I'm here mentioning is more around software testing or integration testing, where we don't want to just test the AI accuracy, but we also want to test integration of microservices of our end-to-end application. Does the application logic is in line with the model inference? And then deployment, this is standard in cloud terminology, or in modern software lifecycle, we say CI/CD, continuous integration, continuous deployment. And you can use various tooling for that. So for example, when you push code change, it runs your integration test, creates artifact, deploys them, and then you can have monitoring and observability, which is a very important step in machine learning engineering, because models generally they degrade their performance over time. And we want to make sure the model performance is high enough for production. And if it isn't, then you see the arrow going back. We start do more training, or we grab a different model that is trained and better performance. So here's a question for you. What role do you play? Are you a data scientist, or you consider more of yourself an engineer? Depending on what roles you play, you would, in this life cycle, your work would be focused around the first half, which is the model training, building of the model, or in the second half, which is model deployment, productionizing it. Again, for Java developers, the way to do it is these days is to do it on the cloud, and to take these giant enterprise Java applications in the cloud. There are a couple of strategies for that. You can move your existing big monolithic application, or you can refactor it into a microservice. So for example, there are two frameworks that are very popular. One is called Helidon, and the other is called Micronaut. They're both open source frameworks. And the people who are working on this actually work at Oracle, and we have put them out on GitHub. And they make writing code really fun, scalable, fast, because you're writing small microservices that are talking to each other over REST endpoints. And these services can be containerized in Docker containers. And the containers can run in an orchestration manner through Kubernetes, all the modern cloud benefits, so that your applications can scale. One microservice can be written on Java, other one could be in Scala, other one could be in Python, for example. So it allows for portability, ease of coding, best technology used for the job at hand, maintaining large code in an easier fashion. So if you are a data scientist, data engineer, I just want to plug various Oracle Cloud services that you can check out. I'm not going to talk about these, but just want to show you that you can do all kind of stuff, from doing Spark, Hadoop jobs with Oracle Big Data services, or you can do machine learning using R and Python notebooks, using Oracle Data Science services on the GPU, etc., etc. This coming soon is actually live now. So yeah, you can run these on GPU, NVIDIA GPUs. This talk is more focused around ML engineering, or ML engineering for Java engineers. And I took a screenshot of this tweet by this lady Chip, who's pretty popular on Twitter, as you can see her followers. And she wrote recently, machine learning is 10% machine learning and 90% engineering. So if you are a Java engineer, you're pretty much in good hands, because of the 90% of the work, you can leverage your background knowledge, Java development knowledge, engineering knowledge. And the 10% that you need to learn about machine learning, I'll cover at the high level, and then I'll give you pointers where you can go and learn more. But it's really exciting time to be a machine learning engineer, because it's a new role that has opened up in the industry. It's very popular, and the skill set needed are from engineering background. And as you know, Java is #1 language in enterprise, software. That almost all the companies, they're using Java somewhere or the other. And a lot of the companies these days, they want to leverage machine learning. And to deploy machine learning within these large Java ecosystem, best ways to use Java libraries. So I talked a bit about cloud native deployment. I just want to show the slide that kind of gives you some idea of cloud native architectures. So microservices are very popular. And microservice, it is not the only way. There is also room for monolithic applications. It really depends on the use case. And the way to go about is that microservice is one way. There is another technology in cloud native called serverless function. Serverless function are nothing but a function that runs on the cloud. So you just call one function, and that one function could be used to do machine learning inference. So you have a model, and it's deployed, and you call this one function from your existing monolithic app or microservice app, and it gives you the prediction, and you render that in the client and do whatever logic you want to do with that. So if you want to read more about microservice, you can go to this link. I'll put these slides out there so you can check them out. And the way to architect a modern ML cloud native application would be to at various endpoints. So in this example, let's say we have some HR application, and we can grab users' detail, for example, last name or department name or search by title. And this is how the client application will request through this URL endpoints. Make get or post, put standard REST methods. When these are invoked, they would call a microservice. So microservice is based on the service-oriented architecture, but it's a smaller service versus a large service. You break it down, and these services could be doing all kind of job in the application. It could be, rendering the UI. It could be making database calls. It could be making ML inferencing calls to the model and rendering the result to the client. If you have any question, just please feel free to type it in the chat box. I'll be happy to answer them in the end. So I mentioned there are two basically important technologies in what we call cloud native: serverless function and microservice. Serverless functions are functions, and there is a project called FN project. It's an open source project, and it open source from Oracle, and it allows you to write serverless functions, and you can deploy them on any cloud, or you can run them on your laptop. At Oracle, we also provide a managed service for running serverless function called Oracle Cloud Function, and it makes it really easy. And this project, you can write functions in Java, Node.js, other languages, Go, etc. And the two frameworks I already mentioned, Micronaut and Helidon, very popular for writing microservice architecture, microservice applications. And they're lightweight. The Helidon comes in two forms. One is more friendly to Java EE developers, Java microprofile, and the other one is more convenient for Java SE developers. So you're writing in plain old Java SE microservices. And again, this is how you can architect your microservices. So like I was saying, you can have a model repository where you host pre-trained models for your business, and you can get those models at these URI endpoints. And the repository can have multiple models for the same thing. So for example, if you want to swap one model with the other, its performances or its scores accuracy is not very good, you can call a different model at a different endpoint or a different version number. And this way, we are adding software engineering best practices to machine learning models. Because right now, data scientists and data science community, this field is new. It's called ML engineering or ML ops. And it's applying cloud DevOps ideas, software engineering principles to ML. And so example here is you can have a cognitive service or text service for your application. So example, your medical uh, hospital, and you wanna make application simple for medical providers to upload MRI or X-ray, and the application would call a cognitive service that would do classification, would classify this X-ray showing fracture or is not showing fracture, or this image, is it showing person has COVID or not, right? It's trained on a lot of data, and you can deploy them through the cloud. Or similar thing for text, you can do all kind of things, sentiment analysis, classification of text, etc. So the exciting thing is that there are a bunch of libraries and frameworks nowadays for Java engineers, starting with the most popular framework in general, TensorFlow. There's active work happening in the community called TensorFlow for Java. It's a special interest group, meaning it's an open access group where people are where they're essentially porting TensorFlow for Python library to Java. And it's already out there, and I'll show demos using that. It's currently, the latest version is version 0.2.0. And this maps to TensorFlow Python 2.x version. The Java version is different, but it maps to the latest TensorFlow version. And it's friendly, Apache 2.0 license. And another big library in machine learning is called PyTorch. And PyTorch also has been open source for Java by Facebook. Although it's lacking documentation and examples, it's kind of very basic right now. But the good news is that all of these frameworks are being ported to Java so that Java developers can use them. And it opens up the possibility so Java engineers don't have to, forget everything they know and learn Python and learn these libraries. Because you can then do everything you can do in TensorFlow, for example, you would be able to do it in Java. Or another use case is that you can work with a Python data scientist. They can train the model in, let's say, PyTorch, and you can use the model and you can do the inference in Java using PyTorch for Java. So it opens up a lot of possibilities. Another good library is called DJL. It's by AWS Labs. And another one by Oracle recently announced called Tribuo. It's a machine learning library, and it's really user-friendly. Documentation you can check out on tribuo.org. And then there's a popular library which has been around for a while now. It's called DL4J under Eclipse Foundation. It's very heavy duty. It has all kind of features and functionalities, including Spark, ML. And I put some strengths and weaknesses here that I thought of. These are very subjective. You should try it. Your mileage may vary, but the good news is that there are many ways to do machine learning and deep learning in Java now. So what is a neural network? Neural network is basically essentially a graph, a bidirected graph, which acts as a function approximator. Meaning this graph does various operations. As you can see, the circle, those are the nodes of this graph, and we have edges, which are the arrows. And generally data flows from input towards the output. And the data, first step is to transform the data so that you can load the data in this graph. Once you transform it, then you do various operations on the data. And these operations happen in these layers called hidden layers. And then finally, what you get is an output or a prediction. And I'm explaining this in more detail in a bit. So for example, let's say we want to do image recognition. So the computer, we pass it images, but it doesn't really understand images, right? First step is to transform the data from images to pixels. And the pixels, we are reading them, we load them in a matrix or vectors. And the vectors, so for example, this picture of a car, let's say this has 2,500 pixels. This image could be a PNG or a JPEG. Now these are 50 by 50 images, so 50 horizontally and 50 vertically, each pixel dimension. So their total is 2,500. And this is, if this is a RGB image, meaning it has colors, then we have 2,500 times 3. So it would be 7,500 values, because we have the XY dimension, and then we have each RGB has its own 2,500 value, the intensity of the color. And we represent this in form of this something called a vector, or it can have many dimensions, so it becomes a tensor. And when we run the deep neural network, one use case could be classification. So we train on many such examples of cars, and then we deploy in production, and somebody uploads an image of a motorcycle, and then we don't want the model to return it as a car, right? We want it to return it as something, it's not a car. So we train it using various different type of data, not just car, so it knows what is not a car and what is a car. And then the way you create the learning algorithm is you create a classifier. Goes further more detail into this. So feed forward neural network is a simple neural network. So for example, here, we can have a neural network trained on 4 different type of images: pedestrian, a car, a motorcycle, or a truck. And we want it to give us a prediction when it sees a new image. So it's been trained on many these type of images, and then when it sees a new image of, let's say, motorcycle, it would return a probability or a score or prediction. So as you can see in this graph here, in the last layer where it's been annotated, if the image is of a motorcycle, it should give a higher prediction that this is a motorcycle. For example, it should say motorcycle 95% probability, car 25%, pedestrian 10%, truck 85%. And then your job is to take generally the highest score and then do something with that, because that's the most accurate prediction. And to do all of this, the neural network does various operations like I described, and I'm going to describe them further. But at this point, I want to make one comment. So all of this happens in a very low level, essentially matrix multiplication or linear algebra. That's what really happens, what these libraries are doing underneath. And right now, to do that, we use these frameworks use something called ND arrays. And if you have any Python experience, you may have heard about this library called Numpy. It's a very popular library in Python, and all it allows is to do these matrix multiplication in Python, because Python natively doesn't have support for that. Neither does Java. But NumPy became very popular. It allowed for Python researchers essentially to run these neural networks. The good news is that Java is getting a native support under Project Panama to do these matrix multiplication. It's actively under work. If you're interested, you can check out something called Project Panama Vector API. What that would allow is to do these matrix manipulations, calculations on this CPU called SIMD operations using Java. So Java would call the native APIs, and it would improve the performance significantly. And right now, but currently the way we're doing is we have ported ND arrays to Java so using various libraries. TensorFlow has implementation of ND arrays. TensorFlow for Java has implementation of ND arrays. DL4J has implementation of ND arrays. ND arrays means n-dimensional arrays. So that's what allows for linear algebra on deep neural networks. So further, a little bit more theory, what is happening here is essentially the neural network, it does operations on the nodes, and then finally, what happens is it does something called activation function. An activation function, it basically normalizes the result, essentially between between -1 and +1. So if various nodes, return results more than that or less than that, it puts it within that parameter. And there are different type of activation function that mold the results differently. They're called linear activation function or nonlinear, and nonlinear examples is sigmoid function or softmax function. This is more theory of machine learning. You don't need to know, but it helps to know some of these terms and concepts. And what we are doing during training is that we want to get the model as accurate as possible, and we want to reduce the loss. So in order to reduce the loss, we use something called loss function. Loss function, one example is called mean squared error, MSE. It's very commonly used for problems of regression. There are other types of loss function for classification problem, image classification. Another term you will hear a lot is called optimizers. Optimizer are something which optimize what the loss function is returning. So the popular optimizer are stochastic gradient descent, Adam. There are other optimizers. What they're doing is basically the model, when it's training, when it's learning, essentially, it's calculating loss every time, at every iteration. And the goal is the loss to go down. And to go down, there are various algorithms. One popular is called gradient descent algorithm, and something called back propagation. So when I showed you the model here, it's arrows going forward, but there's also an operation that happens when the arrows go back, which is called back propagation, where model is re-engineering essentially its weights to improve its prediction based on the given input. So I won't go into much detail into that, but at a high level it's good to know, because that really the learning is happening forward and backward passes. And there's a learning rate, which tells model what should be the learning, how often it needs to learn, and you can set those values. Another important concept to know is fitness. Sometimes you will hear we have overtrained the model, undertrained. So overtraining would be if the model has seen a lot of data of the same type. So for example, your training data and testing data, generally they should be different. But if they are very similar, then the model has already seen that data before. Then it has been overtrained, and it would fail when it will see new type of data. So overtraining is not good. Neither is undertraining. Undertraining means you haven't trained it with enough data. It has been undertrained. It has seen very little data, both in training and testing. So most likely in real world, it would fail. Something called epoch, which is a larger training, how many times you want to run these iterations. And you run the iteration generally in batches. These things are important to know, because when I'm going to show you code, the code will use all of these concepts and ideas and will write them. So steps at high level are defining a neural network with some learnable parameters or weights, iterate over them, process these input through the network, compute the loss, propagate the gradients back into network parameters, update the weights. Some of these operations, the model would do it on its own. All you have to do is define the algorithm, the functions. Some of them we have to do more work, especially around data cleaning and getting the right type of data. So let's dive into the demo. I will switch from here to my code. Can I get a time check? How much time do I have left, please? Nelsie?
Yeah, you still have 10 minutes.
Okay, 10 minutes. Okay, not a lot of time, so we'll go fast here. I have here this application running, TensorFlow, and I call it Hello World TensorFlow. And as you can see, this is importing TensorFlow. I'm going to quickly show you the POM XML file. So to do this in your Java project, all you have to do is add this dependency. And this would import TensorFlow for Java. And I'm also using Helidon, so I've imported that. And TensorFlow for Java is a very simple program. What we're going to do is we're going to initialize a graph, Because remember the graph I showed you, every operation in TensorFlow happens inside a graph. And the operations happen inside something called a session. So I'm going to create a session here, and I'm going to create a tensor object, and I'm going to provide it, I'm going to grab a simple value from it, which is the version of this TensorFlow. And then we're just going to print that. That's all it's going to do. And the way we're going to do that, we can run it directly, but I wrapped it in a simple Helidon microservice. So this is, again, I'm importing Helidon here. And I'm not going to explain Helidon too much, but what I'm doing is I'm calling TensorFlow, instantiating TensorFlow. And I'm just running inside this Helidon microservice. I'm running TensorFlow, run TensorFlow, and it gives me a prediction. Right now, the prediction, instead of prediction, it's going to return me the TensorFlow version. So let's just quickly do that. And to do that, I will run this piece of code right here. So as you can see, it's the started microservice, localhost. And I'm not doing, like I said, very fancy, but simply I'm just printing what TensorFlow returned me. Hello from TensorFlow version 1.15. So it's just printing version number. But here you can imagine it can print a score, the prediction of your model. If we were to do a different, if this service called a different TensorFlow model instead of the hello world is right now, we're just printing. So I have more interesting example here. This here, we're using TensorFlow for Java to label images. And you see this very often. This is a computer vision example where I'm going to provide it a label. Let me run this. I don't want to type all of this. So I'm just going to find whatever. Let's just type it up. Let's just run this code. So right now, because I'm running it directly, the problem is, okay, I need to pass in two arguments, model directory. Let's do this here. So all I'm doing is I'm running the program, but I have to provide it as first argument, the model directory, and the second argument is the image that we want it to detect for us. So let's do this right here. And I'll show you. I have a couple of images here right here in the resources, test images. So this is, for example, let's say we made an app where users can upload images of any animal, and a model would return what animal it is, the label. So I am using a pre-trained model, Inception model, that I downloaded from Oracle Cloud Object Storage. And this model has been trained. So the good thing is, machine learning, we don't have to scratch everything from scratch. We can use pre-trained model. That's the use case I'm showing here. So in your Java app, you have a pre-trained model you can grab, And you can retrain it if you like, meaning you can train it again, or transfer learning, it's called. You can train the model for your images. So it is already trained on a bunch of images, but you want to train on your images, let's say your pet animals. The model, what it is trained on, this model comes with this label, this file that shows it has been trained on all of these type of animals. And these are the labels. So what the program is going to do, the program is going to run this. So it's going to take the first argument is the model directory. Second is the image file that I've typed in here. First step is going to do is going to load the model, the pre-trained model, this file. It's going to serialize the model in a byte array, because that's what TensorFlow needs to perform its operations. Then we're going to give it the labels. The label, this file that I just showed you, which has all the animals. And then we're going to give it the image, the file that I'm passing, the new image that we want it to run the model inference on. And that is stored again as a byte array image. And here, essentially what I'm doing is I'm executing the model. So the way to do it is I have a helper function here. It's called construct and execute graph to normalize images. And so what it does, it takes the images, it initializes the graph that we need for TensorFlow to do anything. And we call this, we have a graph builder class, we instantiate that, and images, the model is trained on images of certain dimension. So we have to normalize. So if the images that we are providing it, it is not 224 by 224, this function would normalize that image because it needs to be this scale at this value and no zoom. And then it does that operation. And then in the session, it actually runs the model. And it runs this operation. So what the next step we do it is we generate a label of probability. So remember I showed you the list of the labels. Now each of them will get its own score. The model will say the probability this cat is 10%, this panda is 25%, this whale is something 45, 90% or whatever. Generally we want this to be the highest. It can be a gray whale, or there is another whale in this model, killer whale. So one of them we want it to be the highest, and that would be this one. So what we do is we grab the maximum value of the probability using this function max index that the model gave us, and then we print that. So that's what it's going to do. And then down below are mostly helper functions, because this image data I'm manipulating, I'm grabbing the maximum index of the probability, etc., etc. So running the inference, and in any time, it should return said best match killer whale 41.59%. Great. So good thing that it was able to detect this image as killer whale, which it is, and not any other kind of image, including the other whale that it had in its label. But bad thing is the score is not very high. It should generally, because if we want to put it in production, it's not a very good idea to put a model that's returning at 41.59 probability. So the one thing what we can do is most obvious, that we need to train this with more and more such images of killer whale. And then it'll score will hopefully go up. And then we can do other things, including optimizing the performance of the model in the model code itself. So this is one example. Now, this I'm running it as a Helidon microservice, but it's so easy that you can see this one I'm actually running it on the terminal. On the previous one I ran it in the microservice, but you can see how this piece of code, because all it's doing is inferencing, that we can have this function called as a microservice, right? This function execute, not a microservice, it could be a microservice, but it could also be a serverless function. So a serverless function, would call this function, and the serverless function lives in the cloud. And that's how you can use, you don't have to, do a whole bunch of changes to your code, but you can have one serverless function that does model inferencing. And that function is called either directly on your client or in your business logic elsewhere. So that's that. I also want to show one other demo here, which is a different example, more sophisticated. It's around a linear regression example, simple linear regression.
Maybe you can wrap up.
We can wrap, we don't have much time. Okay, so all right, well, let's then skip that example. I want to mention a few other services with Java. So remember I showed you the slide model. Once you have the model trained, you want to put the model in production. So to put the model in production, there are open source libraries and projects out there. There are two of them, one is called GraphPipe, another is called MLflow. And they allow you to do various things, including model tracking, monitoring the performance of the model. And they have Java APIs. GraphPipe also came from Oracle, by the way. Another interesting technology to know is Onyx. So for example, if you have a model, right now I showed you examples with TensorFlow, and it has a special format of the model file. Let's say if you train the model in PyTorch and you want to use it in TensorFlow application, you can do that by using Onyx. Onyx, it's a layer where it allows for interoperability. Model trained in one format, you can use it in another format. And it's an open source project, and check it out. Another exciting thing is Java Visual Recognition API, which is API easy to use that allows you to do visual image recognition. And this is a JSR spec. It's going to be publicly available soon. It's been approved, and it's very exciting news. But there's another way to do at least computer vision in Java. And finally, there is a project which allows you to do notebooks. You can run notebooks on the cloud for machine learning, just like you can do for Python. And that makes it more fun. So you don't have to code in IDE. This is my slide to conclude the things we talked about. Libraries to do deep learning, there are many. And you don't have to do everything from scratch. You can just do inferencing using pre-trained model. You can run them on the cloud. There's these frameworks, and you can do performance and monitoring. With that, thank you very much. I also have a book coming out, and I have a newsletter. You're welcome to sign up if you go to this link, bit.ly/AI-Java, and I'll take any questions, or you can email me, reach me on Twitter, email. I'd be happy to answer questions. Thank you.
Cool. Thank you. That was a super interesting topic. And yeah, I've learned a lot from this. And yeah, thank you for joining us, and thank you for sharing your expertise with the rest of the community. And we hope that we'll see you again.
Okay. Thank you very much, everyone.